Welcome back. So I see the words pattern 1, pattern 2, pattern 3. This is a sequences, patterns and sequences question. So we need to go to that section in our log tables to support us and scaffold us. So we're looking for the word sequences. There's no word pattern, it's sequences. And series, because when you add up the numbers in a sequence you get a series. So in fact all the different types, linears, make quadratics and so on. We're not expecting to see a geometric because we haven't done them yet and they're not in the paper, but we will see a linear sequence and a quadratic sequence, and we will look on page 22. Okay, so I believe in a thing called a universal design for learning. For me to design everything to give you every single chance to learn. So what I did here is, because we're teaching through the medium of English, I cut out the Irish side, okay, and I blew it up large so you can see it. That's my teaching tactic, called a universal, part of what's called universal design for learning. People who have bad eyesight can see this better because it's bigger, and people who get distracted by the busyness of the Irish side over there. So which would you like? That one, this one, or this one? Which is better? See? Better. Okay. To begin with, it won't be very algebra mathsy. It'll be very visual. Draw pattern 4 in the sequence. So we don't have to read this now. We can draw pattern 4, which from what I can see is you take this one and you put another one underneath it, which will have 4 little boxes. So tactically, to draw it, it might make sense. So to come in towards the middle, might make sense to use, I want to make sure now I don't go down too far, but I think 2 boxes, so it's around the same size like that. And then if 2 boxes, I'm only going out 1 box and down, and I'm going in 1 box and down, and I'm going in 2 here and down. Okay, and that pattern can continue. But during and right now, I've never done this before, I'm learning as I do it. Okay, I might just do something cool and switch it over to black. Okay, see, this is my new one. There's this alternating pattern where you take where you join and you go that way and that way. Okay, so that's the next pattern. Here's a table. Now complete the table. I'm reading for understanding. I'm ready to underline to show the total number of bars. 1, 2, 3, 3. So 1, 2, 3, 4, 5, 6, 7, 8. 8. Now we don't know it's linear. Well, I know it's linear because there's a thing if it's going straight. Actually, it mightn't be. Let's go. So it might not be linear. 1. Let's go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? Because I wanted to be organized and have a system. So I said I'll do all the verticals. I'll go up to the horizontals. I'll go back up to the verticals. Okay, so I developed a strategy, and you can't do that before you go into the exam. You might have done it differently. Now I can check, is it a linear sequence? It isn't, because I went up 5. We can start doing our first differences now. I went up 5, then I went up 7. Now you know you're going to go up 9. Now you can count all them, and we probably do it for fun, but I could also just say I know it's going to go up 9 because that's the way this course is. This is a linear sequence, it's going to continue. And then I also know it's going to go up 11. So it's going to go up to 35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. What am I talking about? Oh yeah, that's here. Got afraid I messed it up. Okay. Great. That confirms it, but I didn't have to do that. Okay. Now, tick the correct box to show what kind of sequence is made by the number of bars in each pattern. So we know if you're going up by an odd number, if your first difference is a linear sequence. Look, your second difference is 2, 2, up 7, up 9, up 11 is 2, 2, 2. Okay, so that'll be our justification is second difference is a constant. So it's quadratic, and justification second difference. We don't use the letter N, D really for that, but it's called a second difference anyway. The second difference is always 2. That'll do us. And as long as it's always a fixed number, that's fine. Show that the nth term of this sequence is n squared plus 2n. Now we can go with the algebra method, and I promised you we'll go with the more standard. So what I'll do is I'll do the algebra method here, and I'll do the number method here. Now the number strand is where these sequences are, and they're there for a reason, because you can use number strategies, which we did first in class. But actually the book uses algebra technique, so I'm going to use algebra technique first. Okay, so for that, first of all, they do tell us it's n squared, because we dear God. So the way we would have done this is we'd have said, well, we could say, okay, so they've showed that the nth term of the sequence is n squared plus 2n. They have done first, but I'm going to pretend we didn't know. I'm only going to pretend we knew. This is what you would normally do. Term n is equal to half of 2 is 1, so I wouldn't have a variable there, plus n squared plus bn plus c. I'm just going by convention because that would normally be called a. Okay, so I'm going to do it out fully and figure this out. Okay, so we know term 1 equals 1 squared plus b plus c, and we know its value is 3. This will be the first of our two simultaneous equations. Term 2 equals, now 2 squared is 4, and that'll always be the case. 2 will go in front of b, that will always be the case, and we don't know c. Well, they told us it's not, but we'll pretend we didn't know because it'll be more realistic not to know. They should have said it was n squared plus a n plus b, find it out. That would be more of a challenge. And that's 8, because when I put 2 in, I get out 8. Okay, now I want to keep everything done here, so I'm going to be pretty tidy here now. Transpose over to 1, we get 3 take away 1 is 2. Transpose over to 4, we get 2b plus c equals 4. Now plus c, so subtract up, we'll get rid of the c. Subtract up, you get 2b take away b is b. The c's cancel, subtract up, b equals 2. Now b equals 2, so c equals 0, and you're done. But watch this, guys. So you could also just go to your calculator, and you could have filled in n squared plus 2n and just shown you get the same numbers. You could also use your calculator in the following way, and this is really, really cool. You could go into the statistics mode, pick your quadratic equation, which is option 3, and then you could say, even though it says x, you could say I'm going to fill in 1, 2 and 3. You do need 3 points, not 2. Okay, and now I go to y value is 3, 8 and 15. This is really cool. I want to get this slanted at the right angle for you. So we get 3, 8 and 15. 3 equals 8 equals 15 equals. Okay, now I can AC option, do my regression calculation. That'll tell you all your unknowns. You get 8. Now you have to be careful here, because the C means what goes in front of n squared. So it's 1n squared plus 2n. Okay, so regression on calc, you could do a equals 0, b equals 2, c equals 1, with a plus b n plus c n squared. Okay. Of course, you could also do our stepping back. This is the real number method over here. Okay. You could bring this back to 3, and 3 take away 3 is 0, and that's the one in the box. So then you could say term n, way we did it here was, we know it's n squared because of the 2, because of the 2 second difference. Then here tells us it's 0, and then remember, using term 1, you could say 1 squared, so no, this is a 1, use that 1, because when you put 1 in, this becomes 1. So 1 and 0 and b, 1 and b equals the middle, which is 3, so b equals 2. Okay, then you have 1n squared plus 2n plus 0. Okay, and there's lots of other ways. So there's lots of variations and alternatives ways of doing things. This is the traditional way in your book, and we've finished. I'm spending ages on it, aren't I? Because I'm teaching you. A pattern in this sequence is made using 99 bars. Work out, so wow, they're going to go way down long, and they're going to end up getting 99, way bigger than this. I could keep going and we'd get there, but that would be exhausting. We could use the formula to get it, or we could use algebra. We're going to use algebra because we love it and it's analytical. All the other ways are a bit too easy, so let's use algebra. Okay, there's the formula. N squared plus 2n. With the correct n value, we'll get 99. So this is understanding equals and saying set this equal to 99. This is an equation. Is it in standard form? No. Transpose back to 99. N squared plus 2n minus 99 equals 0. Now we're expecting a natural number, so we don't really ever expect to use the minus b formula. You can, and you'll get the right answer, but we're trying to find, look, it's really easy, I think, two numbers that subtract to 2. Definitely subtract to 2. So two numbers 2 apart that multiply to 99. Okay, we'll use the big frame. Not that you have to, but the two numbers are 11 and 9. The big thing is to know, I'm looking for two natural numbers, first of all, where they subtract to 2. So these are your numbers. We'll use an n here, and one of them must be negative, but you know which one. You make the big one have that plus. Okay, and one of them must be negative and one of them must be positive. So you start by that and you make it big, because it was the bully, it was the one that made the war of sign turn out to be positive. So you definitely know the bigger one will be positive, and you get this. So now we're solving, we factorized it into n plus 11 times n minus 9 equals 0. And when you do your zero product rule, when you set that to 0, you get minus 11. That has to go. That's not allowed. Okay, or you get n equals 9. Now sure enough, you can quickly go back here and go 9 squared plus 18, 2 9s. And we get 99, so we're definitely right there. Okay, and we only expect one answer because we've thrown away the other negative answer. Done. Okay, of course you could have used functions, I'm going to show you. Or you go to table. You fill in using an x. Alpha x squared plus 2 alpha x. So I've filled in the formula they gave me, and I'm going to run through it. Let's put that up to quite big. You can go up to 29. Okay, you can make it really big, but don't go bigger than 29 because your calculator will blow up. It'll say it doesn't have enough memory. And you just keep going down here until your calculator says 99. There it is. And you come over here then, you say the answer is n equals 9. Now you might say, how do you show you did that? And this is where we had some arguments in class, or at least, now, and I have to double check. I favor this, but if you did this, you would say, well, you could show your table. You could say I'm plotting n and n squared plus 2n. This is how you'd show it now. Now here's what we think. So you could say, we don't want to show them all. You could, but you could say, when I put in 7, I get 63. When I put in 8, I get 80. And when I put in 9, I get 99. We could say, sure, that's... No, examiner wants, and I'll probably use red pen, so hopefully you're not going to use red pen. It's too late now at this stage, because if you're looking at this, your exam is over. So you do that, and then that'll give you the marks too. Okay? For this method. We'll be probably practicing them more and more as we come up to the exam in June. Okay, let's have a look. Right, ready to grade? First things first, even though it's broken down inside as well, we'll just have a look from the summary of all the marks to see what question 4 is worth. Question 4 is worth 30. It's worth more than 15, 25. No, it's not. No, it's worth 25 marks. Again, sorry, it's 5, 10, and 10. 5 for the first bit, then 10, and then the last two bits are jumped together as 10. Again, anyway, we're going to be seeing it here while we correct ourselves. Okay, we have 4 rows. Yeah, we got that one right. And we also have to get this one right, which we did, so we get 10 out of 10 for those two. Okay. Is it quadratic? Yes. Justification, any of these. Second difference is constant. Second difference is 2. The fact that we have this done out would give us full marks. As I said, it doesn't matter where it is on your sheet, except other valid reasons. Okay, so we get 5 out of 5 for that one. And now we're down into, and all of this we already know the answer, except the one at the end here. So, pattern number 9. Okay, now maybe I didn't tidy up at the very, very end, make it explicit. I said n equals 9, that would probably do it. N minus 9 equals 0, n equals 9, pattern number 9. So that's something we'll add on. Look, it's on page 9, that's a fluke. Pattern 9 has 99. Okay, so that's something for me to remember the next time we're correcting it, is to bring it out and say that. But I'm still giving us full marks, right? So we've 10 out of 10 for that. Okay. As always, look at that, it's bouncing around too much. I will see you in the next one, which is question 5.